Alright then, in this video I'm going to talk about the intensive form production function. So this is something that flows from the assumptions we talked about on the production function itself, but also on perfect competition. And I think dedicating an extra video only for this, because I think this is a topic which is very important but also often neglected to be dealt with properly. So what is the intensive form production function? It's very simple, right? You assumed CRS. So by CRS, y is this and lambda y is f lambda k lambda l. So if you take lambda to be 1 by l, then y by l is f of k by l comma 1. Now y by l is output per capita, k by l is capital per capita, or capital per worker is a less awkward term which is generally used. Now notice on the right hand side, in place of labor in the original function, you have 1. And so you only care about k by l on the right hand side. So we can rewrite this as y equals f of small k, where small y is defined as y by l, small k is defined by k by l. Right? So small y is purely a function of k, and this is a new function. This is small f, not capital F. This is a new function. So let's just derive one such function to be clear. Let's assume this is k alpha L1 minus alpha. So y by l is k alpha by l alpha. So y is equal to small k by alpha, right? So here f is equal to k alpha L1 minus alpha, and small f is equal to small k alpha, or k by l alpha. So these are separate functions. That's the point I'm trying to make. So this is the intensive form production function for a CRS technology. And the lesson is that you can express capital output per worker purely as a function of capital per worker if it is a CRS production function. Alright, now a few things about the derivatives of small f, and I think this is a point which is often missed, right? You just assume f to be concave without actually deriving it. So let's understand here. We assumed, remember, we assumed f kk, f ll negative, f kl positive, and f lfk obviously positive. So let's look at a few things now, right? Y equals f of k. Rewrite this as this. Okay. Now differentiate this with respect to k first. So capital K, by the way, respect to capital K. What do you get? You get y, I'm so sorry, this is y k. I'll just write this. Okay, yeah, yk by l equals f dash k by l into 1 by l by chain rule, and these get cancelled. Now yk can be written as fk. So fk is equal to f dash k by l, which is f dash small k. So this is a connection which you have to prove. You can't just assume, as many texts do, that this holds, right? So the point is fk equals small f dash k. Okay, and so f dash k is positive. So f dash k being positive is not an assumption, remember, it is a outcome of your assumption on the extensive form or capital F production function. Okay, all right, now let's look at wage and rental rates. This is again something which props up very often and is not explored, I think, sufficiently in a lot of books. So Write y equals to L into f of k by L. This is obviously from this equation, right? Now differentiate with respect to n. Okay, what do you get? You get yl equals f k by L plus L into f dash k by L into minus k by L square. So this you can write as f of small k plus, this gets cancelled, right? So you get minus small k f dash k, right? Now we know R equals fk and W equals fm. But these are in terms of capital F, whereas the Solow model, as you will see, is solved in terms of small f, small k, etc. So it's crucial to know the link between W and R and this small f. So we get R equals fk, which is equal to small f dash k, right? Why? Because of this. And W equals f of k minus k f dash k from here. Now notice something immediately. R is an increasing function of f dash k, right? So if f dash k rises, R rises, right? But it's a decreasing function. Wage is a decreasing function of f dash k. So if f dash k rises, W falls, right? This is just something for you to keep in mind. Again, this is something which will be explored later on when we look at the dynamics of wages and rental rates. But these two results are really, really important, and you derive it in this way. So this is as far as the intensive form production function is concerned.